Okay, so today we're going to look at some applications using what we've learned about parabolas, about writing equations of parabolas and looking at how parabolas change and some of the basic ideas of them. I really need you to focus here because these are a favorite for the test people. They like to write these and like to make you to put these on there. So usually if you have an excellence question, it's going to have something like this on it. Okay? But we've built everything. It's very straightforward as long as you will let it be very straightforward. Okay? So the first thing I want to do is remind you that about writing equations. There are two scenarios. Sure, that's not how to spell scenario. There you are. All right. First, it's when you know the x-intercepts. Then that's the one where you use that y equals x plus p, x minus q plus c business. Okay? Plus or minus, by the way, right? Can be either one. You just find the value where it's crossing the x-axis and you put them in the parentheses. Remember, the big deal there is to change those signs. So make sure that when you put the number inside the parentheses, you change the sign. Okay? And the second one is when you know the vertex. And that's the one you use that y equals a times x plus b squared, and again it's plus or minus, plus c. Right? Two different forms, and they depend, and which one you use is going to be dependent upon the type of information that you can find from the equation. This one's the easiest, but this one's not bad either. Okay? Now remember, I forgot to put the a there. Sometimes you'll have to find the a, and you find the a by just using any point on the graph to be able to find the a, and then plug in the x value and the y value, and then solve it. And we'll remind you of that today too. Okay, sound familiar? Look good?
Yep.
I hope. Yep. All right. Well, today what we're going to do then is we're going to look at some applications that use this information. So we're just going to go to the example first. And we'll walk through the example. Whoops, that's not the page I want. Hold on just one second. All right. So we're just going to look at this so that you can kind of see, because this one's a really good one. It gives you an idea of what it is that you're going to be doing when you're dealing with these. So a feature of a skateboard park is to be modeled on a parabolic shape, so a parabola. It has a width of 10 meters and its greatest depth is 0.5 meters. So we're talking about the graph of a parabola, and this one is opening up, right? And they have to give you some information about where the measurements are taken. It says if ground level is represented by the x-axis and the y-axis is at the left edge of the curved surface, calculate the equation for the parabola. So I think that your first step should always be, first, draw those axes in. Axes, plural. Okay? Make sure that you know where the pieces are. So in this particular case, if this was on graph paper, that would be your y-axis, and that would be your x-axis, right? It says your x-axis is at ground level, and your y-axis is where the thing starts on the left. Well, if that's the case, and this is 10 meters, then I know that I can find my x-intercepts. Okay? The first one right here is where x equals 0. And if it's 10 meters long, or wide, then that means that's where x equals 10. Right? So I know that I can write the equation of this parabola. It's just y equals a times, the first one is x plus 0, and I'll clean that up in a minute, don't worry. The second one is going to be x, not plus 10, but minus 10. Now let's clean it up. That gives me y equals a times x, because x plus 0 is just the same as x, right? Times x minus 10. Okay, so easy to find the equation as long as you just draw in your x and y axes so that you can look at it as a graph instead of just a picture. Okay, all right. Now, we need to find out what a is, if we can, and that's pretty easy because we can find the vertex of this one very easily. Remember that the vertex is the point where that's exactly halfway between the x-intercepts. So in this case, halfway between 0 and 10 is 5, right? So at that point, x equals 5. And it tells you how deep it is. So at that point, y equals negative 0.5. So I know the vertex is the point 5, negative 0.5. Be careful for the sign. Remember, you went down. It doesn't say negative, but we know it's negative because we're down below the x-axis. Really watch those signs. That's going to be an issue if you don't pay close attention to where the point is. Don't just use the numbers that they put on there. Make sure you think about where they're located in relation to the x and y axes. Okay? Now, then we'll just plug those in to the equation and solve it for a. Okay, I'm just going to write on this page. Sorry, it's messy, but so my y is negative 0.5. Well, they've done it here. So negative 0.5, here is where they put it in, is a. X is 5, then x is 5 minus 10, which gives me negative 0.5 equals a times 5 times 5 minus 10 is negative 5, right? Which gives me negative 0.5 equals negative 25a. If you multiply those parentheses out, 5 times negative 5 is negative 25, and negative 25 times a. We just need to solve for a. Since it's multiplied by negative 25, the opposite of multiply by negative 25 is divide by negative 25. So negative 0.5 divided by negative 25 gives me a equals 0.02. Negative divided by negative is positive. 0.5 divided by 25 is 0.02. Okay, so that gives me my final equation with my a in it. Make sense? So the same thing we were doing before, just presented in a slightly different way. So if you weren't having any trouble writing the equations, then you shouldn't have any trouble here. Okay, now I've got to get rid of this, so no one's going to freak out when I push the button and all my writing disappears, right? Remember, it'll still be in the recording if you want to go back and look at it some more. Okay. Now, is that all that we're asking? I guess so. All they wanted was the equation. They didn't ask any questions about it. Okay. Remember last time we also talked about the idea of a maximum and minimum. If this is the bottom, that point there is a what, guys? A minimum, right? Because it's at the bottom. But oddly, if we were describing this, we would say that the maximum depth is 0.05 meters. So be careful about the terminology. It's actually a minimum, but a minimum is also a maximum depth. because minimum, you're using the, you know it's down because you're talking about a depth. So you can use the terminology both ways. It is a minimum, but you can also discuss it as maximum depth because this word tells you that it's down. It's the furthest down you can go. So a minimum is also the same as a maximum depth. Okay? Does that make sense? So watch out for terminology. Think about words. They can use combinations of words that mean something else. Okay, good deal. All right, let's look at another example real quickly. Again, you're going to see that most of these are the same, have the same kind of idea. It's the only thing is, well, this one has lots of questions, but the only thing is that you have to pay close attention to the equations and the information they give you. So, the weight of apples that Morris picks in his orchard follows a quadratic model. Okay, so that means it's a parabola. And the equation, y equals negative 0.01x times x minus 16, where y is the weight in tons that is picked on any day, and x is the number of days that since he started picking. My first inclination here, whoops, sorry, let me stop turning things blue, would be to draw the graph. If you don't have the graph, you have the equation, I would always start with drawing the graph. Okay? And again, it could be just a sketch too. So we're talking about a graph with a y and an x-axis. And since that's just plain old x, if you set that equal to 0, that means your first x-intercept is here, where x equals 0, which is the origin, right? Then the second piece is x minus 16. If you set that equal to 0 and add 16, all it really does is change the sign. So remember, you don't have to show as much work as I do, but I'm always trying to show you exactly why things are happening. Okay? Because some of you may still be having questions about that. So that means over here at 16 is the other intercept. Okay? Now, looking at this information, we can start answering some of the questions. For how many days does he pick apples? Well, the maximum number on our graph, so this graph is doing something like that, just if you sketch it. The maximum number of x, which is x is the number of days, the maximum number of days here on this side, we go all the way across, is 16. Oops. And I've made a mistake here. Because this graph is negative, right? Did anybody catch that? I've drawn it upside down. This first term is negative, so it should be going up and then down. I did that on purpose. Okay? And it can't exist anywhere down here because can you pick negative apples?
No.
Nope. And it can't exist anywhere over here because you can't have negative days, right? So all we're talking about is that first quadrant. So you could even just draw it in that first quadrant if you want to. If you see things where you know that things can't be negative, then you can just draw that part of the graph. We've looked at examples where we had that before. And then you have 0 here, 16 there, and it goes up like that somehow. Okay? So you don't even have to draw the entire graph, but do put in a drawing. Oops, sorry. Let me get rid of that junk. All right, so there we go. We know our graph does this. We don't know the maximum yet, but that's one of the things we're going to be looking for, so don't worry about it. We'll be able to find it. So for how many days did he pick apples? He picks apples for 16 days because that's the furthest to the right you can go. Yeah? Easy peasy? Okay. Because if you go beyond 16, then you start going into negative days, and that can't happen. On which day did he pick the most apples? Well, the most apples would be right there in the center, which is called the maximum, also known as the vertex, right? And we can find the vertex from this type of equation. This is the one with the intercepts graphed. We can find that by finding the x value and solving for y. And we can find the x value because it's halfway between, because it's halfway between 0 and 16. And 0 and 16 is day 8. So on which day did he pick the most apples? On day 8, because that would be where the vertex is. Okay? What weight of apples was picked on the day he picked the most? So on day 8, just plugging 8 in for x for the equation and working it out, you get 0.64. And remember that, let's see, they gave us a unit, but did they give us a unit in our original equation? Weight of the apples he picked. Okay, weight in tons. Y is the weight is in tons. So do not put just a number. When you're doing these applications, make sure that you also include units. Okay? Then, let's see what else he does. On which days did he pick 55 tons? Well, in that case, we're looking for days, and days is an x value, right? We have tons. Tons is a y value. So all we do is plug in 0.55 in place of y, multiply everything all out, excuse me, and then solve for the y to get the x. Now when you do that, you get x equals 5, and you get x equals 11. Remember, this is a quadratic equation, so you're going to end up with 2 answers when you solve these. Okay? So when you do that, you get 2 answers for 5 and 11. And I'm just going to run through that because I want to remind you of how to solve those quadratic equations. So here we have that. We multiply times that. So that doesn't solve the equation for us. It just gets it ready to solve. 55 equals negative x times x minus 16. What they've done is they've divided by that to turn that into 55. Okay. Then, but we can't solve it like this. We first have to set it equal to 0. So we need to multiply out all these parentheses. Okay. And then we're going to have to refactorize it. Yeah, I'm going to say factor. Y'all are going to say factorize. So correct me. Feel free to correct me. So it's negative x squared, multiplying that times that, plus 16x. Move this in positive 55 to the other side by subtracting it from both sides. Okay. So I have 0 equals negative x squared. And then we can factor it. Factor out that negative. The 2 factors of 55 that'll combine to make 16 are 5 and 11. And in order to get them to add up to make that, but make a negative, well, what we can do is just change all those signs because I don't like that negative in front anyway. So to add to make 55, but to give you a negative 16, they both need to be negative. And then set them equal to 0. And solve. So you get 5 and 11. And it's 2 different days that he picked that, but that's expected because remember a parabola goes up and then it goes down. So at those particular days, you're going to have the same amount twice, right? Okay. So if you remember solving quadratic equations, if you need a review of that, then I'll put that up, and I'll put up a video for you for that if you need to. Just remind me. Okay. All right, so pay attention to what information is given, and that'll tell you what you need to do. So what I want to do is, right, we've got our 3 pages of exercises there. I'll work a couple of them with you. So what I want you to do is just kind of glance through and decide which ones do you want to see. So anybody at all, just decide which ones you'd like to see, you think would looks, which ones do you think look the most fun? Anyone?
I mean, the first 3 are all different. They're like
Yeah, I was thinking the same.
through all the things.
Okay. Yeah. Well, let me just I can kind of walk you through what's going on here. Let's see. So the key to working with this one is that you need to know the maximum, right? The vertex. This is one where you know what the intercepts are going to be. So if it's just plain old x, that means that this intercept is x equals 0. So that means this intercept is x equals 2. What's halfway between between 0 and 2? Is 1, right? Okay. So I'll get you started. So that's a 1. So that if that's x equals 1, then we can find the y value for there, right? So that means we can find the highest point by substituting 1 in place of the x in the equation and then working it out. Okay? Then the next thing they do is they tell you they want to know how long this is. If that's 1 meter, okay, to find the height of the horizontal row of lights. So how high is that? Well, high is a y value, right? Looking for a y value. Well, in order to find a y value, you have to know a what?
X.
An x value. Excellent. Good. So, and we can find that x value by just thinking that this is 1 meter, right? It says the lights are 1 meter long. This is 1 meter, and right in the middle of it is 1. So we're looking for a point that is half a meter that side and half a meter this side, right? So that means 0.5 for this side and 1.5 for this side, right? So you know some things because of the symmetry. You know some things about this. So you know that right down the middle, that middle point is 1, is where x equals 1. So if this is 1 meter long, then that's half, and it's split in half. 1 meter split in half is 0.5 and 0.5, right? So it's 0.5 on one side, 0.5 on the other. So on one side you subtract 0.5 from 1, on the other one you add 0.5 to the 1, and that'll give you the other 2 values. Make sense? Now, do I need to work both values to find the height of the row of lights, I mean?
No.
No, because it's straight across, right? So however high it is here, it's the same height there. So you can use either this one or this one because they're both going to return the same y value. Again, that's the beauty of the symmetry of these problems. Okay, let's look at setting up a couple more of them. Now, I'm not going to set them all up because, you got to do some of this work, make your brain work. Here we go. First, here's one. We don't have a graph, so what we're going to do is sketch the graph. In order to sketch the graph, this is one that gives us intercepts. There's one intercept. Is x equals 0. Again, don't pay attention to the a when you're sketching the graph. That doesn't come into play until you start graphing the actual parabola itself, finding the y value. So in this case, x equals 0. Is one of the intercepts. X minus 8 means that it's going to be positive 8. obviously couldn't be -8 because they don't even have that on the graph. It's positive, which means it's opening up. Okay. And it's a pond, so ponds can't exist in the air. So we're talking about a graph that's doing something like that. Now, I don't know exactly where, but it's easy to find. The maximum depth is the same as finding the minimum value. You see what I was telling you about, be careful with those words. So we know that halfway between 0 and 8 is 4. So that's our axis, that's our line of symmetry. So all we have to do is plug in x equals 4 into the equation to find our y value, right? And that'll tell you the depth of the pond, because y is the depth of the pond. How deep is the pond? 1.5 meters from the edge. Okay, well, that means x equals 1.5, so you just plug it in and work it. Okay. Sounding logical? Don't get too creative. If the width of the surface water is 7 meters, calculate its distance below ground level. Well, if it's 7 meters, that means that some of this, because remember this was going from 0 to 8, right? If it's 7 meters, that means that half a meter is taken up with like coping or edging or something like that. Okay. So you can work through that. So that's like 0.5 and 7.5. Again, you're going to have to work through these and kind of think through them. All I'm doing is kind of getting you started here. Here you have a rope hung here. Lowest point of the rope is 2 meters below the bar, so that means we know a depth. Now this time, we don't know these pieces, but we know the depth. So this one is not the x-intercept equations. Well, yes, it can be, actually, because they tell you the left end of the rope is at the origin. So that's the origin. So x equals 0. Well, and this is 6 meters long, so that's 6. 2 meters gives you the y, so you can find your a very easily. Your vertex is at 3, 2, right? It already gives you the vertex. Okay, so then you can answer the questions. So again, they're just based on being able to find the same kind of information that we used for finding the equations of graphs. Here they just give you another one, and it's up higher, so just pay attention to where it's located, right? Because it's x. This one doesn't have any x-intercepts, does it? It's hung up in the air, so it does, and the ground is the x, so it doesn't have any x-intercepts. So we need to find the vertex, and then use that other formula, y equals a x plus or minus b squared plus c, to find the equation this time. Okay. All right. Then they're asking you, Amy, is this tall? Will her head hit the rope? Well, if she's that tall, she's standing at that point, just find just plug that in and solve it to find out if she's touching the rope. Find out what the rope is doing at that point, how high it is. Okay. Now I want to go to, this one is kind of like the light ones, except that the shingle is at the bottom. This one, notice that there's got a dotted line here to finish off the parabola. That's because this guy is hitting the ball, and remember, you don't usually lay on the ground when you hit a ball, right? So he's standing up when he starts it, so that means the ball already has some height before you begin. Okay? So that gives you a y-intercept, but here's your x-intercepts here and here. So you can still use a negative x-intercept even though it doesn't really exist. Well, you can still use it. So you can still use it to write the equation. Okay? So if it's -2, then it's just going to give you x plus 2. Right? So don't be confused by that. And here's the one that I think if you're going to have any trouble with, is going to be this one. Anybody know why I think you're going to have trouble with this one by just looking at the picture?
It's a triangle.
Yeah, it's a triangle.
It's not like everything.
So, but what's happening is they're moving the values in a certain pattern. So I want to talk about that pattern and then talk about why this is in this section. If you move those patterns, what's going to happen is this little point is going to swing back around. That's your minimum value. So you could model the movement of that point using a parabola. Okay? You don't care because you're not going to use a parabola to solve this. Instead, they're going to ask you, they want you to, the right angle triangle, they want you to find some more values for the x. Now, super easy if you'll look at what's happening here. If x is 10, the other side is 90. If it becomes 20, then it's 80. So what's happening? The x values are going up by what? How many units? 10. And the y, and not the y values, but the other side, this side, it's not a y value because, right, it's just the other side, is going down. So as x goes up by 10, this one goes down by what? 10. So if I used 40, what would this become?
60.
If I used 50, what would this become?
50.
Now, I'm mad at them because in order to answer the next question, you need one more value. Okay? So if you do 40 times 60, you get 1,200. If you do 50 times 50, you get 2,500. Okay, be careful. I'm sorry. The reason why I got 1,200 and 1,250 is because remember the formula is after you multiply the base times the height, you have to divide it by 2, half of it. So 40 times 60 is really 2,400, but divided by 2 gives you the 1,200. So you see where those numbers are coming from? I'm telling you that you can't answer the next question unless you then use 60 so that you can see what happens. Okay? That really irritates me too. But unless you use 60, you're not going to be able to answer every question, every part of this question. Okay? Now, what do you notice about these two numbers every time? Is there a pattern other than they go down? As one goes up, one goes down, what do you notice about the two numbers?
They all equal 100.
Exactly. So, if you have x, this one is 100 minus x. That, guys, is something that comes from optimization problems. It is a classic example of a test question. And they especially love test questions like this because it's a question about a parabola that doesn't use a parabola. But it's still a quadratic equation. So the equation is y equals a times x times 100 minus x. Now, I gave you the equation because this one irritates me, and I don't want you to freak out and not do it. So I want you to go back and do it, but try to think about what the hints that I gave you. Okay? All right, because I don't want to work your homework for you because that doesn't do you any good. Otherwise, I could just show you all of them and you could go and ace the test. You've got to really think it through and on your own. But I do want to give you some hints so that you can do them. Now, here's the key. If you do them and you have trouble, then do it again until you don't have trouble. The only way to get better at doing these is to do not a ton more of them. Don't go to some book or some website and find a million more of them. Do the same one over and over and over until you understand what's happening with it. Does that make sense? Okay. So Don't go and find more. Instead, just do the same one over and over until you really understand. And I should have given you enough hints that you should be able to do any of these. The answers are also in the back of the book. I want you to check them as you go. So do number one, then check your answer for number one. Make sure that you're doing it right before you move on. If you can't get number one right, then move to number two and see if you can get it. If you can't get number two right, then stop working them all together. Just don't do the homework until you talk to me first. Okay? I don't want you to teach yourself how to do it wrong. Okay? So, I didn't tell you not to do your homework, but don't do it wrong. Okay? All right. Well, then that's all I have for you guys. Let's stop the recording.